Good day, everyone. Welcome once again to our discussion today. So we're still on our topic on differentiation rules. All right. And for this discussion, we are going to focus on our topic on the product rule. All right. So if you have f of x equal to some function of x multiplied by some other function of x, then our derivative of the function equal to this some function of x multiplied by the derivative of the some other function of x plus the some other function of x multiplied by some function of x, derivative of some function of x. Okay, so for example, example number 1, if we are given f of x equal to the quantity x cubed plus 3 multiplied by x squared plus 5, then using the product rule, so our f prime of x is equal to, so if you look at the product rule class, so our first term, we have the product of the factor here, some function of x, all right, and then multiplied by the derivative of some other function of x, then plus some other function of x times the derivative of some function of x. Okay, so here we just copy, this factor. Okay, so you just copy that one. So you have x cubed plus 3, then multiplied by the derivative of this. So for this one, we can apply the power and sum rule at the same time. Okay, so using the power rule for this, we have derivative of x squared, so we know that the power will go down, right? Then multiplied by the base, which is x, then the exponent is 2 minus 1, but 2 minus 1 is 1. So if the exponent is 1, no need to write that exponent. That is understood to be 1. Alright? Then plus derivative of constant is equal to 0. Okay, so we are already for this part here. Alright, so for this one. Then plus, you have the some other function of x, which is this one. Alright, so this one here. So you just copy this. Okay, you just copy this one. So we have x squared plus 5, then multiplied by the derivative of this, meaning this quantity. So the derivative of this quantity, so we have derivative power formula, derivative x cubed is equal to 3x squared, then plus derivative of a constant is equal to 0. Okay, now we can simplify this. So f prime of x equal to x cubed plus 3, then 2x plus 0, so that is 2x, then plus x squared plus 5, then multiplied by 3x squared plus 0, so this is 3x squared. Alright, so f prime of x is equal to, so you can multiply this, distribute and multiply. So we can distribute 2x and multiply to its term. Similar to this one, you also have to do that. So multiply. So we have 2x times x cubed. So 2x times x cubed. So this is 2x to the fourth. The log exponent, you just add the exponent of the two. The basis here is x and x. So the power of this x is 1. The power of this x is 3. So when you multiply them, so the power will be added. So that's why we have 2x to the fourth. Then 2x times 3. So this is plus. So we have 6x. Then plus, we have 3x squared times x squared. So we have 3. Then x squared times x squared. So we have to add the exponents. So 2 plus 2, so 4. Then plus 3x squared times 5. So that is 5x squared. Now we can combine similar terms. So we have term here that contains x to the fourth. Right, so 2x to the fourth, and then we have 3x to the fourth. So adding them, so combining them. So we have 2x to the fourth plus 3x to the fourth. So this is 5x to the fourth. Then you have, so let's arrange the terms in descending power of x squared. So we start with this one. Of course, we start with this and then followed by this 5x squared. So 5x squared, then plus this 6x. So this is our answer. This is a derivative of the given functions. Product. Derivative of the product of the given functions. Okay, so do you have any question? So another example, if we are given, say, so example number 2, if we are given f of x equal to 2x to the fourth plus 3x and times 2x minus 1. And we are asked to find the derivative of this function. So the derivative is f prime of x equal to, so again applying the product rule. So what you're going to do is just copy the first factor, okay, and then multiplied by the derivative of the second factor, okay, and then plus the second factor multiplied by the derivative of the first factor. Okay, so this factor and this factor. In this case, we have 2x to the fourth plus 3 is our first factor, 2x minus 1 is the second factor. Okay, so the rule is simply copy the first factor. Okay, so the first factor is 2x to the fourth plus 3x then derivative of the secant factor. So what is the derivative of this? Derivative of 2x is equal to 2 minus derivative of 1 is a constant, so that is 0. Okay, so plus, you have to copy the secant factor. Okay, so our secant factor is 2x minus 1, then multiplied by the derivative of the first factor. So derivative of this, so you combine, we will use the power formula together with the constant multiple rule and the power rule, as well as the sum rule. Okay, so derivative of this, we have 2, right? And then this power will go down, 2 times 4, then you have x to the power 4 minus 1, so that becomes 3. Okay, then plus derivative of 3x, that is equal to 3. So f prime of x is equal to 2x to the 4th power plus 3x, and multiplied by 2 minus 0, so that is 2, and plus we have 2x minus 1, and multiplied by, so this will be 8x cube, then plus 3. Alright, so we can do the same as what we did a while ago. In our first example, you just distribute and multiply these two. Okay, and also this. So for this one, you have to multiply the first term with each term of the first quantity, and the second term with each term of the first quantity, or you can multiply this one here. You can do it this way. It's the same class. You multiply that one and this one, and then you multiply this and this one. Okay, so we have f prime of x equal to this becomes 2 times 2, that is 4 x to the 4th power, then plus 2 times 3x, that is 6x, then plus, okay, so we have 2x times 8 x to the 4th, so that would be 16 x to the, so the exponent here for x is 1, the exponent of x here is 3, so you add exponent, so 16 x to the 4th power, then this plus 2x times 3, so that is 6x. Okay, and then we have negative 1 times 8x cubed, so that is minus 8x cubed, and then this one minus 1 times 3, so minus 3. Alright, so simplifying, combining similar terms, we have 4x to the 4th plus 16x to the 4th. Then we have here 6x, positive 6x, another positive 6x, so we can combine them. So therefore we have f prime of x equal to, so combining these two, 4x to the 4th plus 16x to the 4th, so we have 20x to the 4th. Alright, so let's follow this with 8x cubed, so minus 8x cubed, So we're putting the exponents, no, in descending order. So 6x plus 6x, so that is 12x, and we have minus, so minus 3. Okay, so let's check if we miss or we did not miss anything. We have 16, so add the 2. So 4x to the 4th plus 16x to the 4th, so that is 20x to the 4th. Then we have here 8x cubed negative, so negative 8x cubed. Then we have 6x plus 6x, so that is 12x. Then minus 3. Okay, so this is our answer. Alright, so that's our example number 3. So another example, if we are given, say, okay, so number 3, if we are given this function of x equal to 3x plus 4 raised to a power 6 multiplied by 4x minus 7 raised to a power 3. Right, so let's apply our product rule. So product rule, so we have g prime of x, or derivative of x, is equal to, so the rule says that we just copy this first factor. So we have 3x plus 4 raised to a power 6, then multiplied by the derivative of this. So this time we are going to use the other notation of the derivative, the one that I've shown you last time. So we will make use of this symbol class, the derivative. So multiplied and multiplied by the derivative of this term, this second factor, which is 4x minus 7 raised to a power 3 with respect to x. Okay, then plus second term, we just copy the second term, 4x minus 7 raised to a power 3, then times the derivative of the first term, or the first factor, that is 3x plus 4 raised to a power 6 with respect to x. So this time, class, we are going to combine the product rule as well as the general power rule. Alright, so this d, then subscript x, will indicate, class, that we are going to use the general power rule for this. Okay, so we have, for the first part, first term here, so g prime of x is equal to, so just copy this one, 3x plus 4 raised to a power 6, then times, so applying the general power rule. Okay, so power rule, it means the power, this power here, can you still remember the general power rule? If you have the derivative of if you are given f of x equal to u to the n, and if you are asked to find the derivative of the function, so we have bring this down, n times u to the n minus 1, then times the derivative of u with respect to x. So we're going to use that formula. Okay, so we have here, we just for the first term, we're not yet getting the derivative here. We just copy this one from the formula. So just copy this one, and then we'll take the derivative of this part here. Okay, so using the general power rule, so the power will go down. Okay, so 3 then times 4x minus 7, then the exponent now is n minus 1. This is our n, so n is 3, so 3 minus 1, so this becomes 2. Okay, times the derivative of u, so this is our u. Okay, so derivative of u, which is, okay, so we'll just rewrite it. So derivative of 4x minus 7 with respect to x, then plus, okay, we just copy this. We have 4x minus 7 raised to power 3, then again power rule, general power rule, so this will go down, so times 6, then we have 3x plus 4, then raised to power n minus 1, 6 minus 1 is 5, then times, so we have the derivative of 3x plus 4, so 3x plus 4, then with respect to x. Okay, so equal to, simplifying, so we have 3x plus 4 raised to power 6, so we have 3 times 3, this is times 4x minus 7 raised to power 2 times derivative of this, so we apply the sum rule or the difference rule, so derivative of 4x, that is equal to 4, then derivative of a constant, which is 7, is 0, so minus 0. Okay, then plus, we have 4x minus 7 raised to power 3, then times 6 times 3x plus 4 raised to power 5, then derivative of this, so derivative of 3x is 3 plus derivative of 4, 0. Okay, so this is plus, so simplifying, so we have g prime of x is equal to 3x plus 4 raised to power 6 times, we have 3, this is 4 minus 0, 4 times 3. Okay, I'll just rewrite this so that you can follow this step by step. Okay, so this becomes times 4. Then plus, we have 4x minus 7 raised to the power 3 times 6 times 3x plus 4 raised to the power 5. Then 3 plus 0 is 3. Okay. So g prime of x is equal to, here we have 3x plus 4 raised to the power 6. So 3 times 4 is 12 multiplied by this. So we have 12 times 4x minus 7 raised to the power 2 then plus we have 4x minus 7 raised to the power 3 times we have 6 times 3, so that is 18 multiplied by 3x plus 4 raised to a power 5. Okay, and then simplifying this, rearranging, so this is multiplication, so you can write the constants first. So g prime of x equal to, so you can write the constant first, that is 12. Then we have 3x plus 4 raised to a power 6 multiplied by 4x minus 7 raised to a power 2, then plus, so writing the constant first, to have 18 multiplied by 4x minus 7 raised to a power 3, then times, we have 3x plus 4 raised to a power 5. So you can use parentheses or this bracket, so that's alright. Okay, so this is our derivative of the given product. Okay, so I think that's all for this part for our product rule. So I hope you have been able to follow the step-by-step solution of these problems, these sample problems, and hope to see you again in our next video. So in our next video, we'll talk about quotient rule. Alright, so thank you very much. Have a nice day, everyone, and keep safe and healthy always. God bless. Bye for now.